Listen here, everyone. In the question, one question is mentioned that the CDF of first random variable given that u is equals to f of x, and then CDF of another variable is given as 2v of 2v, which is given as g of x. So both are cumulative distribution function, and it is mentioned in the question that they are identically distributed. Identically distributed random variables. What is meant by identically distributed? Identically distributed means nothing but the value that mean will take is equal to 0, and the PDF of both will be same. As PDF is not given over here, but the CDF is given, so we will talk in the term of CDF only. So you can see the graph over here. These both graphs are looking they are looking like to similar to each other, like -1 to +1. It is the function of f of x is taking the values from -1 to 1, and rest other place -infinity to -1 it is 0, and then +1 to infinity is also 0 in both the cases. So we need to now check what will be the equation, that final equation we'll get when we equate both graphs. So look at over here. F of ux, x is a random variable whose CDF is given as f of v of x, and wait 1 minute. Yeah. So f of v of x and is equals to f of v of x, as they are identically distributed functions. So what will be the CDF according to the formula of CDF given? The probability that the random variable u is going to achieve. So we will add on all the probabilities up to this small x. Let's say it assumes some finite value x. So is equals to p of v. V also, v is less than x. That is what the probability which the first random variable will the probability of the first random variable to occur will be exactly similar to the probability of the second random variable to occur, because they are having the same CDF and the same PDF also. Okay, and that is what it is mentioned, they are having the same CDF PDF. So when we plot like this, now we come over here. In the question itself it is stated that the second CDF will assume the CDF value will assign to g of x. So according to this question, probability 2v will be less than equals to x, because since fv of x was assuming the probabilities u of x is assuming the probabilities from u up to x. So the same way as 2 is multiplied over here, so we will multiply with the coefficient of, that is 2, to this random variable, and we will integrate up to less than equal to x till the random variable we assume the value less than equal to x. We'll integrate all the values. So what we'll get over here, p is where probability v is less than equal to x by 2. So f of v x by 2. So f of vx is equal to f of x equal to probability of v less than equals to x. Okay, like this we'll get. So g of x will be the second random variable's CDF, and this f of v of x was the first random variable's CDF, that is random variable v CDF, and g of x will be the CDF of the second random variable, that is 2v CDF. So from the graph we can state v is less than equal to probability of v less than equals to x by 2. This is the second equation. So now we will plot a graph, and check out how many values are common between these two functions. So like we are plotted the graph from minus infinity to x. The first random variable u is assuming the value from minus infinity to x, we can see, and the second random variable v is assuming the value from v up to less than equal to x by 2. X by 2 comes just before x, so second random variable, that is 2v, will assume the value, the lesser number of sample values or lesser number of weight than the first, because the second, this one x by 2, comes after the x in the negative axis domain. When we talk about, firstly x will come, then x by 2 will come, so x by 2 will come over here somewhat, so x by 2. So second variable sample, second random variable will have a probability greater than the first random variable seed probability. So the number, as the number of the probability is increasing in the second case, so ultimately the samples will also increase, because if the sample will not increase, how can the probability increase? So like over here, so we'll subtract from x by 2, we'll subtract to fx, like gx minus fx firstly will come. Okay, so now we can see what will come over here. If x will assume greater than 0, value greater than or equal to 0 and less than infinity or up to infinity, then the value, as we have seen in the first case, the random variable u, if we talk about, then from here to infinity, that is from let's say x is lying over here, so greater than 0, greater than 0 up to infinity it will occur, and the gx will be greater than x by 2. Similarly, as we are having v is less than equal to x, and in second case less than x by 2, so this exactly the same way will take place for x greater than x, v greater than x by 2, greater than or equal to x by 2 probability. So somewhere greater than x by 2 means it will increase for here. So when we talk about the positive domain, positive axis, this one is the imaginary axis and this is the real, this one is the x-axis. So if in this case, in the x by 2 will come before x, as in the second previous case we were having the negative x by 2 coming after x, like x is over here, minus x is here, then minus x by 2 is here. So in this case fx will be greater, since we are having x to infinity and gx is having x by 2 to infinity, so lesser number of sample is there in the second case than in the first case. I'm sure you're able to make it out. So like this, if the value is less than, if the random variable assumes value less than 0, so fx minus gx, because fx gx is gx is greater than fx, so gx minus fx is less than equal to, and in the first case the same, exactly same is happening. So what we need to find out, the same equation, which equation will best suit. Like it is not given in the question that the value x is assuming greater than 0 or it is assuming less than 0. It is not clearly mentioned that what the x is actually taking the value, which values the x is taking, whether it is taking the positive value or it is taking the negative value, it is not mentioned. So in those cases we need to talk about both positive and negative also. So simply we'll multiply, let's see what happens when we multiply x with this equation, like x fx minus x into gx. For example, if x value will be less, if x value will be positive, okay, so x value will be positive, then fx minus gx will ultimately come as positive. And if x will be negative, whatever, if even if we multiply the positive part with negative, like say into plus 2, like if plus 2 value we are getting from this equation fx minus gx, and then if we multiply with minus 1, ultimately it will result into negative value. Okay, so we will get the equation in the form of the negative value. And similarly in the positive, if the x we talk about the positive random variable x, if the positive random variable x is assuming the positive value, I mean, then fx minus, so 1 into 1, 1 into 2 will always be 2, so it will always get value greater than 0, greater than equal to 0. So this equation perfectly suits. Thank you. In this video I'm keeping up to this only, and then next video we'll talk about some other main properties of random variable x and what are the other functions related to the random variables, continuous random variable especially, or the mixed random variable.